What if everything we've been told about where life can exist in space is completely wrong? What if the so-called habitable zone is actually holding us back from finding alien life? For decades, scientists have been searching for life using one simple rule: look for planets in the habitable zone, that sweet spot around a star where temperatures are just right for liquid water. But here's the shocking truth. This concept is fundamentally flawed, and it's causing us to miss potentially millions of habitable worlds. The habitable zone assumes planets are bare rocks with no atmosphere, but atmospheres change everything. Take Venus, for example. It sits just outside what we'd call the habitable zone, but its thick carbon dioxide atmosphere creates a runaway greenhouse effect that makes it hotter than Mercury. Meanwhile, Mars sits within the habitable zone, but has such a thin atmosphere that it's frozen solid. The atmosphere is the real game changer now. Imagine planets with super thick atmospheres orbiting red dwarf stars. These stars are smaller and cooler than our Sun, so their habitable zones are much closer in. But if a planet has a thick enough atmosphere, it could distribute heat from the starlit side to the dark side, creating habitable conditions across the entire planet. We're talking about worlds that are tidally locked, with one side permanently facing the star and the other in eternal darkness. Without an atmosphere, the day side would be scorching hot, while the night side would be freezing cold. But with the right atmospheric conditions, life could thrive in the twilight zone between these extremes. But it gets even more mind-blowing. What about worlds with no atmosphere at all? I'm talking about icy moons like Europa and Enceladus. These frozen worlds orbit gas giants far outside any traditional habitable zone, but beneath their icy surfaces lie vast oceans of liquid water kept warm by tidal forces. The gravitational pull from their massive parent planets creates friction that generates heat, melting the ice and creating subsurface oceans that could potentially harbor life. We've seen geysers erupting from Enceladus, spewing water vapor into space, clear evidence of liquid water where we never expected to find it. And then there are the truly exotic possibilities. What about planets with atmospheres made of something other than nitrogen and oxygen? Worlds with methane or ammonia atmospheres could support completely different forms of biochemistry. Life as we know it requires liquid water, but who's to say life couldn't evolve in liquid methane or supercritical carbon dioxide? The more we learn about extremophiles on Earth, organisms that thrive in boiling hot springs, deep ocean vents, or acidic environments, the more we realize life is incredibly adaptable. The implications for the search for extraterrestrial intelligence are staggering. If we've been limiting our search to planets in the traditional habitable zone, we might be missing 90% of potentially life-bearing worlds. The Kepler telescope has already discovered thousands of exoplanets, and many of them don't fit our narrow definition of habitable. But with advanced atmospheric modeling, we're beginning to understand that habitability is about so much more than distance from a star. It's about atmospheric composition, planetary mass, geological activity, magnetic fields, and orbital dynamics. The James Webb Space Telescope is now giving us the ability to analyze the atmospheres of distant exoplanets. We can detect water vapor, carbon dioxide, methane, and other gases that might indicate biological activity. And what we're finding is challenging everything we thought we knew. Some planets that should be frozen wastelands show signs of atmospheric warmth, while others that should be boiling hot appear surprisingly temperate. The truth is, the universe is far more creative than our limited Earth-centric models. Life might be flourishing in places we never thought to look, in the clouds of gas giants, on rogue planets floating between stars, or in the deep oceans of icy moons. The habitable zone isn't a fixed boundary. It's a fluid concept that depends on a planet's unique characteristics. As we develop new technologies and expand our understanding of planetary science, we're realizing that the conditions for life are probably much more common than we ever imagined. The search for alien life is just beginning, and the most exciting discoveries are likely to come from places we once considered impossible. Where do you think we'll find alien life first? Share your predictions in the comments below.